Welcome to the new video where we are going to solve this exercise where we are asked for the area of a circle in square meters. They tell us that the circumference has this equation, which is x squared plus y squared minus 4x plus 6y minus 3 equals 0. We see that we have the equation written in general form and we are going to convert it into its center radius form. Why? To find the area they are asking for. Remember that the area of a circle is pi times the radius squared. So, what I need is to write it in this way to obtain the radius squared, then simply multiply by pi and get the area they are requesting. We have the equation of the circumference written in general form, and we are going to convert it into its center radius form. So, what should I do? You can see that the center radius equation is written in the form of a binomial squared. We have two binomials squared added, and that will be equal to a radius squared. So, what is most important in this part is the coefficient of both x and y, the linear parts 10 and y. As we know, the general equation and the center radius equation represent the same thing, only the form is different. Remember that this is one form and this is another form, but they represent the same thing. In this case, it is a circumference. So, I am going to convert the general equation of the circumference into its center radius form. So, I look at these coefficients of both x and y, and from there, I will extract these binomials squared. These binomials will come out from there. How do I do this? Remembering that the linear part of the squared binomial has a variable, it is the double product of what is inside the binomial, of the two elements of the binomial. So, if it is the double product, then I have to divide it by 2, and minus 4 divided by 2 gives me 2, and obviously the variable will be x. Therefore, the first binomial will be x minus 2, and this will be squared plus y. Now, it follows, you can see here plus 6, the coefficient that y has, which is 6, so if I divide it by 2, then I have y plus 3 squared, and this will be equal to r squared. Where does this r squared come from? You can see that this minus sign is the one that is here. This minus sign is subtracting what is on the left side, so this one that is here is the constant term. You can move it to the right side by adding, but you can see that I have this independent term here. When I square it, it will give me another independent term. Therefore, what I need is that part of the independent term to appear on the left side. That part has to appear on the left side, so I say I square it, and I have to add it to the right side because it already appears on the left side. Remember that in order for the equality not to be modified, what I do to the left side, I also have to do to the right side. So, since I had to add this independent term squared here to create the binomial squared, you can see that I also have to add it here. Therefore, I put plus 2 squared here, and minus 3 squared is 9, so I have it. This part will not change. X minus 2 will be squared plus y plus 3 will also be squared, and this is equal to. Now, if I add everything up, 9 plus 3 plus 4 equals 16. What is the value of a now if I add all of this? 9 3 plus 4 is 7 plus 9 16. What is the value of the radius squared? It is 16, therefore I have just changed the form of the equation, I have not given the answer to my exercise. They ask me for the area and say that the area is equal to pi times the radius squared, and the area is in square meters. So, the area will be 16 pi square meters. Remember that pi represents a number, so I multiply 16 by pi in the decimal approximation that I have, which will obviously give me a number with decimals, an irrational number in this case. But I can also leave it represented as just the area being equal to 16 times pi in square meters. So, when she is working on the exercise and it is not specified that an approximate answer with decimals is needed, I can leave it like that. Both answers are valid, 16 pi square meters and 16 times pi square meters. So that is the answer to this exercise. I hope this video has been useful and see you in future ones.